children. Welcome to today's episode on Modern Periodic Table. Let us today discuss present form or long form of the periodic table. The table, which is based upon the electronic configuration of elements, is called the present form or the long form of the periodic table. Before we go any further, let us first discuss the learning objectives of today's lesson.
On completion of this topic, learners will be able to discuss long form of the periodic table, explain structural features of the present or long form of the periodic table.
Children, let us now once again come back to topic and discuss more on our topic today.
Structural features of the present or long form of the periodic table. The present long form of the periodic table is based upon electronic configuration of elements. With its help, it is very easy to find out the location of the element in the periodic table. The outer electronic configurations of all the elements along with their symbols are given in the present form of the periodic table shown on the screen. The long form of the periodic table consists of 18 vertical columns and 7 horizontal rows. These have been obtained by arranging the elements in order of increasing atomic numbers in such a way that the element with similar electronic configurations are placed under each other in the same vertical column. These vertical columns are known as groups or families, while the horizontal rows are called periods. Let us discuss them one by one. We will first discuss about groups. Present long form of periodic table ਵਿੱਚ 18 vertical columns ਹੁੰਦੇ ਹਨ, ਜਿਨ੍ਹਾਂ ਨੂੰ groups ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਹਰ ਇੱਕ group ਵਿੱਚ similar outer shell electronic configuration ਵਾਲੇ ਕਈ elements ਹੁੰਦੇ ਹਨ। ਇਨ੍ਹਾਂ groups ਨੂੰ 1 ਤੋਂ 18 ਤੱਕ ਨੰਬਰ ਦਿੱਤਾ ਗਿਆ ਹੈ। Mendeleev ਦੇ modified periodic table ਵਿੱਚ ਇਹ 18 vertical columns 16 groups ਵਿੱਚ ਵੰਡੇ ਹੋਏ ਸਨ, ਜਿਨ੍ਹਾਂ ਨੂੰ 1A, 2A to 7A, 1B, 2B to 7B, 8 ਅਤੇ 0 ਦਾ ਨਾਂ ਦਿੱਤਾ ਗਿਆ ਸੀ। Group 1 ਅਤੇ Group 2 ਦੇ elements periodic table ਦੇ extreme left side ਤੇ present ਹੁੰਦੇ ਹਨ। Last electron in all elements of these groups enter the s orbital of respective energy shell, ਜਦਕਿ last 6 groups 13 to 18 periodic table ਵਿੱਚ extreme right side ਤੇ present ਹਨ। Last electron in all elements in these groups enter the p orbital of respective energy shell. In our 8 groups 1, 2, 13, 14, 15, 16, 17 ਅਤੇ 18 ਦੇ elements ਨੂੰ collectively normal ਜਾਂ representative elements ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਇਨ੍ਹਾਂ ਦੀ general outer electronic configurations ਕ੍ਰਮਵਾਰ ਇੰਜ ਹੈ: NS1, NS2, NS2 NP1, NS2 NP2, NS2 NP3, NS2 NP4, NS2 NP5 and NS2 NP6. Group 18 ਦੇ elements ਨੂੰ inert gases ਜਾਂ noble gases ਕਿਹਾ ਜਾਂਦਾ ਹੈ। Groups 3, 4, 5, 6, 7, 8, 9, 10, 11 ਅਤੇ 12 ਦੇ ਐਲੀਮੈਂਟਸ ਨੂੰ transition elements ਕਿਹਾ ਜਾਂਦਾ ਹੈ ਕਿਉਂਕਿ their properties lie between the properties of S and P block elements. In these elements belonging to these groups usually have 1 or 2, 0 in some case, electrons in the s orbital of the outermost shell, that is ns orbital, while the electrons are being progressively filled in, one at a time, in the d orbital of their respective penultimate shell. As such, their general outer electronic configuration is n-1 d 1 to 10 ns 1 to 2, where n is equal to 4 to 7. Two series of elements, each containing 14 elements, are placed at the bottom of the periodic table. Therefore, there are 28 F block elements in the periodic table. The first series of elements with Z is equal to 58 cerium to Z equals to 71 lutetium, which forms part of the 6th period and follow lanthanum, are called lanthanides or lanthanoid. While the second series of elements with Z equal to 90 thorium to Z equal to 103 lawrencium, which forms a part of the 7th period and follow actinium, are called actinides or actinoids. These elements are also called inner transition elements. The s orbital of the last shell is completely filled. The d orbital of the penultimate n-1 shell invariably contains 0 or 1 or 2 electrons, but f orbital of the antepenultimate n-2 shell gets progressively filled in. As such, their general outer electronic configuration is n-2 f 1 to 14 n-1 d 0 to 1 ns2. Let us now learn about the periods. ਜਿਵੇਂ ਕਿ ਅਸੀਂ ਪਹਿਲਾਂ ਹੀ ਪੜ੍ਹ ਚੁੱਕੇ ਹਾਂ, long form of periodic table ਵਿੱਚ 7 horizontal rows ਹੁੰਦੀਆਂ ਹਨ, ਜਿਨ੍ਹਾਂ ਨੂੰ periods ਕਿਹਾ ਜਾਂਦਾ ਹੈ। ਇਨ੍ਹਾਂ ਨੂੰ top ਤੋਂ bottom ਵੱਲ 1, 2, 3, 4, 5, 6 ਅਤੇ 7 ਨੰਬਰ ਦਿੱਤੇ ਜਾਂਦੇ ਹਨ। ਹਰ ਇੱਕ ਪੀਰੀਅਡ ਵਿੱਚ ਅਜਿਹੀ ਸੀਰੀਜ਼ ਆਫ ਐਲੀਮੈਂਟਸ ਹੁੰਦੀ ਹੈ ਜਿਨ੍ਹਾਂ ਦੇ ਐਟਮਸ ਦਾ ਸੇਮ ਪ੍ਰਿੰਸੀਪਲ ਕੁਆਂਟਮ ਨੰਬਰ n ਹੁੰਦਾ ਹੈ। ਪੀਰੀਅਡਸ ਅਤੇ ਇਲੈਕਟ੍ਰੌਨਸ ਦੇ ਐਨਰਜੀ ਸ਼ੈਲਸ ਵਿੱਚ ਕੋਰਿਲੇਸ਼ਨ ਹੁੰਦਾ ਹੈ। The period number corresponds to principal energy level n, and the number of elements in each period are the same as the number of electrons present in the corresponding energy shell. Each period begins with the filling of electrons in a new energy shell. For example, the first period corresponds to the filling of electrons in the first energy shell, that is n equals to 1. Since this energy shell has only one orbital, that is 1s, which can accommodate only 2 electrons. Therefore, first period has only 2 elements. These are hydrogen 1s1 and helium 1s2. The second period corresponds to the filling of electrons in the second energy shell, that is n equals to 2. Since this shell has 4 orbitals, that is 1 2s and 3 2p, it can accommodate 8 electrons. It starts with lithium or Z equals to 3, in which one electron enters the 2s orbital and ends up with neon, that is Z equals to 10, in which the second shell is complete. The third period corresponds to the filling of electrons in the shell, that is n equals to 3. This shell has 9 orbitals, 1 3s, 3 3p and 5 3d. However, we know from energy level diagram for multi-electron atoms that 3d orbitals have even higher energy than 4s orbital. Therefore, 3d orbitals are filled only after filling 4s orbitals. Consequently, third period involves the filling of only 4 orbitals, 1 3s and 3 3p, and thus contains 8 elements from sodium or Z equals to 11 3s1 to argon or Z equals to 18 3s2 3p6. The fourth period corresponding to the filling of electrons in the fourth energy level, that is n equals to 4. It starts with the filling of 4s orbitals. However, after filling 4s orbital, the filling of 5 3d orbitals begins since the energy of 3d orbital is lower than those of 4p orbitals, but higher than that of 4s orbital. Further, the filling of 4d and 4f orbitals does not occur in this period, since their energies are higher than that of even 5s orbital. Therefore, in the fourth period, the filling of electrons only in 9 orbitals, 1 4s, 5 3d and 3 4p occurs, which can accommodate at the maximum 18 electrons. Therefore, fourth period contains 18 elements from potassium, that is Z equal to 19, to krypton, that is Z equals to 36. The fifth period, like the fourth period, also contains 18 elements, since only 9 orbitals, 1 5s, 5 4d and 3 5p are available for filling with electrons. It begins with rubidium, that is Z equals to 37, in which one electron enters the 5s orbital and ends up with xenon, that is Z equals to 54, in which filling of 5p orbitals is complete. The sixth period corresponding to the filling of the sixth energy level, that is n equals to 6. Since in this period only 16 orbitals, 1 6s, 7 4f, 5 5d and 3 6p are available for filling with electrons, therefore sixth period contain 32 elements. It begins with cesium, that is Z equals to 55, in which one electron enters the 6s orbital and ends up with radon, that is Z equals to 86, in which the filling of 6p orbitals is complete. In this period, after the filling of 6s orbitals, the next electron, that is 57th, enters the 5d orbital against the Aufbau's principle, and thereafter the filling of 7 4f orbitals begins with cerium, that is Z equals to 58, and ends up with lutetium, that is Z equals to 71. These 14 elements constitute the first or 4f inner transition series, called lanthanides. These are separated from the main frame of the periodic table and are placed at the bottom of the periodic table. Thereafter, filling of 5d orbitals which started at lanthanum continues from hafnium, that is Z equals to 72, till it is filled at mercury, that is Z equals to 80. These 10 elements constitutes the 5d transition series after the filling of 5d orbitals. Filling of 6p orbital starts at thallium, that is Z equals to 81, and ends at radon, that is Z equals to 86. The seventh period corresponds to the filling of seventh energy shell, that is N equals to 7. Like sixth period, it is also expected to contain 32 elements. Corresponding to the filling of 16 orbitals, that is 17s, 7 5f, 5 6d, and 3 7p. However, this period is still incomplete and only 28 elements are known at present. In this period, after the filling of 7s orbital, the next two electrons, that is the 89th and 90th, enter the 6d orbital against the Aufbau principle, and thereafter the filling of 7 5f orbital begins with protactinium, that is Z equals to 91, and ends up with lawrencium, that is Z equals to 103. Although thorium, that is Z equals to 90, does not have any electron in the 5f orbital, yet it is considered to be F block element. Since its properties resemble more the F block elements than the D block elements. The 14 elements from thorium, that is Z equals to 90, to lawrencium, that is Z equals to 103, constitute the second or 5f inner transition series, which is commonly called as actinides or actinoids. It mostly includes man-made radioactive elements. In order to avoid the undue expansion of periodic table, actinides like lanthanides have also been placed separately at the bottom of the periodic table. Thereafter, the filling of 5d orbitals which started at actinium, that is Z equals to 89, continue till it is completed at UUB, Z equals to 112. These 10 elements, that is actinium 89 and rutherfordium 104 to UUB, constitute the 6d transition series. After the filling of 6d orbitals, the filling of 7p orbitals would begin at UUT, Z equals to 113, and would end at UUO, Z equals to 118, which will belong to the noble gas family. The first three periods, that is first, second, and third, containing 2, 8, 8 elements respectively, are known as short periods, while the next three periods, that is fourth, fifth, and sixth, containing 18, 18, 32 elements respectively, are called long periods. Division of elements into S, P, D, and F blocks. Elements in the long form of the periodic table have been divided into 4 blocks, that is S, P, D, and F. This division is based upon the name of the orbital which receives the last electron. We will discuss them one by one right now. First, S block elements. element in which the last electron enters the s orbital of their respective outermost shells are called s block elements. Since s subshell has only 2 electrons, therefore there are only 2 groups of s block elements. Thus, elements of groups 1, that is hydrogen and the alkali metals, and group 2, that is alkaline earth metals and helium, comprise s block elements. Consider, for example, elements of group 1. Hydrogen has only 1 electron, and this enters 1s orbital. The rest of the elements, that is lithium, sodium, potassium, rubidium, cesium, and francium, receive the last electron in 2s, 3s, 4s, 5s, 6s, and 7s orbitals respectively. These elements are therefore said to belong to s block and have ns1 as the general outer shell electronic configuration. Now consider helium and the elements of group 2, that is beryllium, magnesium, calcium, strontium, barium, and radon. The last electron in these elements also enter the s orbital, that is 1s, 2s, 3s, 4s, 5s, 6s, and 7s orbitals respectively. Hence, these elements also belong to s block and have ns2 as their general outer shell electronic configuration. Thus, the element of groups 1 and 2, including hydrogen and helium, in which the s orbitals are being progressively filled in, are called s block elements. In all, there are 14 s block elements in the periodic table.
General outer shell electronic configuration of s block elements. NS1 to 2 general characteristics of s block elements. They are soft metals with low melting and boiling points. They have low ionization enthalpies and are highly electropositive. They lose the valence electron readily to form +1 in case of alkali metals and +2 ions in the case of alkaline earth metals. They are very reactive metals. The metallic character and the reactivity increase as we move down the group. The compounds of s block elements, with the exception of those beryllium, are predominantly ionic. Most of the metals of this block impart characteristic colors to the flame. We will now learn about the p block elements, elements in which the last electron enters any one of the 3 p orbitals of their respective outermost shells are called p block elements. Since a p subshell has 3 degenerate p orbital, each one of which can accommodate 2 electrons, therefore in all there are 6 groups of p block elements. These are 13, 14, 15, 16, 17 and 18. The atoms of the elements belonging to these groups receive the last electron in 2p, 3p, 4p, 5p and 6p orbitals respectively. General outer shell electronic configuration of p block elements is Ns2Np 1 to 6. The elements of group 18 are called noble gases. Each period ends in a noble gas except helium. All the elements have closed shell Ns2Np6. electronic configuration in the outermost shell. Helium, however, has 1s 2 electronic configuration. The elements of group 17 are halogens, while those of group 16 are called chalcogens. These two groups of elements have high negative electron gain enthalpies and hence readily add 1 or 2 electrons respectively to attain the stable noble gas configuration. The elements of S and P block are collectively called representative or normal or main group elements. These include elements of group 1, group 2 on the extreme left and element of groups 13 to 18 on the right hand side of the periodic table. General characteristics of P block elements. P block elements include both metals and non-metals, but the number of non-metals is much higher than that of metals. Further, the metallic character increases from top to bottom within a group and non-metallic character increases from left to right along a period in this block. Their ionization energies are relatively higher as compared to those of S block elements. They mostly form covalent compounds. Some of them show more than one oxidation states in their compounds. Their oxidizing character increases from left to right in a period and reducing character increase from top to bottom in a group. D block elements. Elements in which the last electron enters any one of the 5 d orbitals of their respective penultimate shells are called d block elements. Since a d subshell has 5 d orbitals, each one of which can accommodate 2 electrons, therefore, in all there are 10 vertical columns comprising 10 groups of d block elements, namely 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. General outer shell electronic configuration of d block elements is
n-1,
d1 to 10 ns, 1 to 2 where n is equal to 4 to 7. Since the properties of these elements are midway between those of S block elements and P block elements, they are also called transition elements. All these are further divided into 4 series called first, second, third and fourth transition series. The first transition series forms a part of the 4th period of the long form of the periodic table. It contains 10 elements from scandium to zinc in which 3d orbitals are being progressively filled in. The second transition series, which forms a part of the 5th period, also contains 10 elements from yttrium to cadmium in which 4d orbitals are being progressively filled in. The third transition series, which forms a part of the 6th periods, also contains 10 elements, that is lanthanum and from hafnium to mercury, in which 5d orbitals are being progressively filled in. The fourth transition series, which forms a part of the 7th period, also contains 10 elements, that is actinium and elements from rutherfordium to eka-mercury or anubium. In all these elements, 6d orbitals are being successively filled in. Thus, the elements of groups 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 belonging to 4th, 5th, 6th and the incomplete 7th periods in which the last electron enters the d orbitals of their respective penultimate shells are collectively called d block elements. Question is, in terms of period and group, where would you locate the element with Z is equal to 114? And the answer is, children, from the periodic table we find that element 114, that is unquadium, represented as UUQ, belongs to period 7 and group 14 of the periodic table. Atomic weight 289, block in periodic table P block, classification metallic. Summary. Today we have learnt about the long form of the periodic table. Children, I hope you enjoyed today's lesson as much as I did. See you next time. Till then, goodbye.